Well, hello everybody. Here is some help on problem set number 5. Not only that, but this video is a review for exam number 2. So first of all, I've got this graph and I want to know what's the function that created this graph. So when I go to the window, right now x is going from 0 to 5, and this scale I put as pi over 6. So along the x-axis, all of the little tick marks are going to be worth pi over 6. And then take a look at the graph. So one important thing when you're given a picture is find one cycle. So this part, I'm just going to ignore that little part, and I'm going to go from the bottom to the top to the bottom. That's one cycle. So really it needs to go from right here, and that's one tick mark, so that's pi over 6, to over here. So this is 1 pi over 6, 2, 3, 4, 5, 6, 7. So on the x-axis, it's going from pi over 6 to 7 pi over 6. Then, if you look at the scale on the y-axis, those are going by 1. So when you go back to the graph, its very lowest is 1, and the very tallest is up here. So that would be 1, 2, 3, 4, 5. So it's going from 1 to 5, and it starts at the bottom, then goes up, so that is going to be negative cosine, and then goes down. So to begin with, the period is this length of this interval right here. So in this case, the period is going to be 7 pi over 6 minus pi over 6. So the period is equal to 6 pi over 6, or just pi. So I then have the formula that period is equal to 2 pi divided by b, and then take this pi and plug it in for the period over here. And now I need to solve for b. So what you can do is multiply both sides by b, that'll put b over here, and divide by pi, so it's going to move over to here. Or in other words, these two can switch places. And then the pi's cancel, so that means that b is equal to 2. So right now I'm working on just the x-axis, or the x information. Now the other x information is this got shifted to the right, so that's called the phase shift or the horizontal shift. And that is pi over 6, or to be a little more clear, pi over 6 to the right. Then for the y information, well, for one thing, I need to know what's in the middle of this 1 and 5. So if you add them together, that's going to be 6. Divide by 2, that's going to be 3. And that number right there that's in the middle, that's the vertical shift. And the last piece of information that we need is the amplitude. And so the amplitude is measured from the middle to the top or the middle to the bottom. Either way you do it, the amplitude equals 2. So amplitude equals 2. And this is the y information. And then finally, I have everything I need for creating the function. So it's going to be y equals, because it's starting at the bottom and then going up, this is negative cosine. And this number needs to be multiplied with the cosine, so it's actually negative 2 cosine. And then I need parentheses, so it needs to be a 2 for this b right here, and then shift it to the right. So that's going to be x minus pi over 6. So x minus actually shifts it to the right. And then the vertical shift, you can either put that right here, so that it says 3 minus all this, or you can put it right here. And then let's see if I got it right. So of course I typed the function in first, and the function I used, -2, and then right here, if you multiply this out, that'll be 2x, and 2 pi over 6 becomes pi over 3, and then plus 3. So this one is correct. So far I have 100%. Then moving on to number 2. So for example, number 2, graph this function. Y is equal to 2 minus 2 times tangent, and then 3x minus pi. So when you have a number that's multiplied with x, this number 3 needs to be factored out. Now you can't factor it out of the tangent, but just out of this with the pi and such. So if I factor that out, it's going to be 3 times. So if you factor this 3 out, it's the same as dividing by a 3, so it's just going to leave x. And now this one needs to be divided by 3, so it's going to leave minus pi over 3. Then for the x information and the y information. So for the x information, the period is equal to, so usually the formula is 2 pi divided by b, but the period for tangent is pi. So this is going to be pi divided by the b, so that's going to be pi divided by 3. And then this is the horizontal or the phase shift, so that means that it got moved over to the right. So the horizontal or the phase shift is pi over 3, or for a little more information, you could say pi over 3 to the right. Now for the amplitude. Well, amplitude means how tall is it? And tangent goes to infinity, so actually this is not applicable for tangent. And then the vertical shift, so that's this number in the front, and it could be right here, or it could say plus 2 at the end. Same thing, that's the vertical shift. Because it's a positive, it got shifted up. Okay, so with tangent, originally, it's got these two asymptotes, in negative pi over 2 and positive pi over 2. So of course our graph is going to have asymptotes as well. Now, one way to do it is, the period is pi over 3. So that means that from one asymptote to the next, that's a total length of pi over 3. So if you measure between these two dotted lines, that's a length of pi over 3. So that means half of it has to be over here and half of it has to be over here. So if you cut this in half, that would be pi over 6. So this would be a pi over 6 positive, and this would be a pi over 6 negative. A slightly different way to do it is, this got divided by 3, so just transfer that information over here, put a 3 down here, put a 3 down here, and you get pi over 6 and negative pi over 6. Now that is just using this. Now we need to take this information and shift it to the right by pi over 3. So now I'm ready to start making my actual graph. So this one needs to be shifted to the right by pi over 3, and this one needs to be shifted to the right by pi over 3. So this would be a negative pi over 6 plus pi over 3, and then get a common denominator, so multiply by 2 and multiply by 2. And this one would be 2 pi over 6 minus 1, so that means that it's 1 pi over 6. So this asymptote becomes this one at pi over 6. And then what about this asymptote? So that's going to be pi over 6 plus pi over 3, and then get a common denominator, so multiply by 2 and multiply by 2. So this will be 2 pi over 6 plus 1 more is 3 pi over 6. And then when you reduce that, it's pi over 2. So the other asymptote is at pi over 2. Now the tangent graph usually goes like this. It goes through the origin, and then this side goes up to positive infinity, and this side goes to negative infinity. The only difference is this one got moved up by 2. So go to 2, and then that's going to be this middle point right here. So then the right side is going to go up to positive infinity, and this side is going to go down to negative infinity. And that one is now finished. Now on to number 3. So this company's sales go from 1,000, whatever they are, snowboards, bicycles, iPhones. So they go from 1,000 at the beginning of the year, and then they go down to 500 6 months later. So it's some type of thing that people like to buy in the winter, but not quite so much in the summer. And then what are their sales in August? So we'll need to sketch graph and then create the function and then plug in the number for August. So for the graph, this is going to be 0 and then a year later, but I'm going to go in months, so 12 months in a year. And then their sales go from 1,000 down to 500. So they're cyclical like this. They go down during the summer and then they go back up each winter. So for this, the period is equal to 12. So 2 pi divided by b is equal to 12. And again, these two can switch places. So it turns out that b is 2 pi over 12, and then reduce that, it's pi over 6. So this is the period. And then for the phase shift, so that means did it get moved left or right? This did not. It's starting right there where cosine usually starts. So this one, there's no phase shift. Then for the y information. So for that, I need to know what's in the middle. So if you add these two, that's going to be 1,500. And if you cut that in half, it's 750. So that middle line right there, which is actually their average sales, that is the vertical shift. So for the vertical shift, it was 750 going up. And then for the amplitude, so that's from 750 up to 1,000. That's 250. All right, now we can create the function. So this is just regular cosine graph. So it's going to be y equals, and then put the amplitude in front, 250 times cosine. And then we need the b times x. And there's no phase shift, so I don't have to put x plus or x minus. And then the vertical shift, so plus 750. And then finally for August, well, usually we call August the 8th month, but right here I started with January as 0, so we don't usually do that. So actually all of the months are off by a little bit, so that means that August means that x equals a 7 instead of an 8. So then just plug in a 7, 250 cosine pi over 6 times 7 plus 750. And let's see, this would be the 6th month when they're at the lowest, and the 7 would be right about here. So that's got to be somewhere between 500 and 750. So I'm going to estimate it's a 632. So if I get an answer like 12,000, I definitely know that's wrong. It's got to be like probably around 600. So this right here is in radians, so make sure that the calculator's in radians. And then 250 cosine of pi divided by 6 times a 7 plus 750 more. Exactly what I thought it was going to be. 533.494. So 533 is actually just off the bottom. So I thought it was going to be closer to 600, but my little drawing right here isn't perfectly accurate. So the math definitely is accurate. All right, then on to number 4. So that was 3 in a row with graphing. Now on to other things that are not graphing. So rewrite this expression, tangent of cosine inverse of x over 12 algebraically. Maybe that's a long word, algebraically. In other words, rewrite this so that it does not have any trigonometry in it, so that it only has algebra in it. So you start with this. When you take cosine inverse of something, then what that equals is an angle. So when I say what's cosine inverse of a half or something like that, then it's telling me the angle. So it's telling me that the angle is pi over 3, just as an example. So anyway, it equals an angle theta. Then what you can do is take cosine of each side. On this side, cosine and cosine inverse cancel each other out, and so it's x over 12 equals cosine of theta. And then you can go back to right triangle trigonometry, draw a right triangle, and this is going to be the cosine. And cosine is adjacent over hypotenuse. So that means the adjacent side has an x and the hypotenuse has a 12. And then we need to do the Pythagorean theorem to solve for this side. So we need a letter on this side. I'm just going to call it a for right now, and then solve for a. So it's going to be a squared plus x squared equals 12 squared. Or if you subtract x squared from both sides, this will be 144 minus x squared. And then take the square root. And because of this minus right here, you cannot reduce this, you cannot simplify, it just stays like that. And then after we've done that, we're only one step away, because this said find tangent of this. So in other words, what's tangent of theta? So tangent is opposite over adjacent. And then this is the answer I was looking for. So this only has algebra in it. Okay, there's number 4. Just 2 more to go. For example number 5, given that sine of A is equal to 5 over 7, find sine of 2A. So you can't just multiply by 2, but we need to use the formula that sine of 2A equals 2 times sine of A times cosine of A. So sine of A, that's going to get replaced with 5/7. Then we need to see what cosine equals. Well, we could do like with the last problem, draw a right triangle. And then sine is opposite over hypotenuse. So if this is the angle A, this is the opposite, and this is the hypotenuse. And then put some variable down here like x, and then solve for x. So we'd have x squared plus 5 squared equals 7 squared. Or x squared plus 25 equals 49. And then subtract 25 from both sides. 49 minus 25 is going to be 24. And then take the square root, so x equals the square root of 24. But that could be simplified because 24 is 4 times 6, so it could actually be simplified as 2 square root of 6. Now we can see what cosine equals. So cosine of A equals adjacent over hypotenuse. So adjacent was x, so that's 2 square root of 6 over hypotenuse. And then finally, sine of 2A equals 2 times, then replace sine with the fraction 5 over 7, and then replace cosine with this fraction, 2 square root of 6 over 7. And then I'm looking to see if I can cancel anything, but I cannot. So the final answer is sine of 2A equals, so this will be 10 times this makes 20. So 20 radical 6. And on the bottom, 7 times 7 is 49. And there's number 5. Only one more to go. And that is verifying a trig identity. So for example number 6, verify that sine squared of x minus tangent squared of x divided by 1 minus secant squared of x, that all of that could be reduced to just be sine squared of x. Well, it looks like we're going to need some identities. Like, I'm looking at this one, 1 minus secant squared. So that actually comes from this identity right here. So if you just, actually you'd need to subtract secant squared to put it on this side, and then you'd have to move the tangent squared. So 1 minus secant squared is equal to negative. Let me just write this on the scratch paper in case somebody looks at this without listening to my voice. So 1 plus tangent squared x equals secant squared of x And then that means you could subtract secant squared from both sides. And then it would say 1 minus secant squared plus a tangent squared. That's all the left side. And right now the right side has 0. And then subtract tangent squared from both sides. And so 1 minus secant squared is equal to negative tangent squared. All right, I think that's where I'm going to start. So you begin with the side that has the most stuff in it. So I'm starting with this side. So sine squared minus tangent squared gets divided by 1 minus secant squared. And then that equals... So when you do these, you should only do one thing at a time. So right now I could do some identities for the top, but just do one thing at a time. So that is replace the bottom with negative tangent squared. Now it looks like these tangent squares could cancel. The only thing is this does not have a tangent squared. So they can't quite cancel, but what you can do is make this into two fractions where it's this divided by this and then this divided by that. So it's going to be sine squared gets divided by negative tangent squared, and then minus, well actually when you break it apart, those two negatives are going to become plus. Tangent squared divided by tangent squared. So supposedly, stuff is going to cancel out and we're only going to be left with a sine squared. Well, these two can cancel and just be a plus 1. And then to simplify this one, I'll leave the sine squared where it is. And then I'm going to use this identity. So take this identity and square both sides. So tangent squared equals sine squared divided by cosine squared. So the negative sign will stay there, and then tangent squared equals sine squared divided by cosine squared. For the next step, when you are dividing by a fraction, that means multiply by the reciprocal. So this original sine squared can stay there. And this negative, I'll just move it to the front right there. And now invert this so that cosine squared goes on the top and sine squared goes on the bottom. And then don't forget our little friend, plus 1. Now this sine squared and this sine squared cancel. So all that's left is negative cosine squared plus 1. And we are actually finished. Because if you look at this identity compared to what we have, so this means that somebody took this cosine squared, they moved it to the other side so it was negative, and there would be a positive 1 and a negative cosine squared. And then that equals sine squared. Let me show you a different way that I've seen students do it, and I sort of like it. They go, oh, 1 equals all this, so I'm going to replace this 1, which typically I don't think of doing. I don't usually think of take something simple and replace it with something more complex, but that's what some people do. So they then go, leave the negative cosine squared there, and then in place of the 1, you can replace that with sine squared plus cosine squared. And then this negative cosine squared and this positive 1 cancel, so all that's left is sine squared. And then put the official little stamp saying we are now done with this review.